Rab explains it all. Math, chem, physics never fall. Subscribe and learn. Ace every test, so Rab explains it best.
Hi everyone, I hope you're doing well. Welcome to this video and welcome to my channel. In this video we are going to learn how to calculate average speed when we have a distance time graph. Okay, let's start with an example. In this example, the question gave us a distance time graph and the question says calculate average speed for each part and for the whole route. Let's pay attention to the distance time graph that we have. How many parts does it have? As you definitely can see, this distance time graph is made of 3 parts. This is the first part. This is going to be the second part, and finally, this one is going to be the third part. What was the formula that we used for calculating average speed? As I told you in previous videos that I'm going to put the link of them in the description, we have only one formula for calculating average speed, and that is equal to S is equal to distance divided by t, which is time here. Okay, let's start for calculating average speed for each part. We want to start with the first part. I'm going to show it with S1. 1 stands for the first part. How am I supposed to calculate distance? I'm going to write d of ending point of this part minus d of initial point of this part, t of ending point minus t of initial point. Okay. What is the ending point of first part? As you definitely can see, this is the ending point of the first part and this is the initial point of the first part. What is the distance of ending point? It is 600. What is the initial point of the first part? As you can see, the distance of initial point is 0. What is the time of ending point? It is 200. And the time of initial point, as you definitely can see, it is 0. So I'm going to have 600 over 200, which is going to be 3. And because I have distance based on meter and t based on second, I'm going to have meter per second. Okay, let's calculate average speed for the second part. Second part, as you can see a horizontal line here, right? Whenever you have horizontal line, it means average speed is equal to 0. But let's calculate it based on the formula that we have. As I told you, d of ending point minus d of initial point, t of ending point minus t of initial point. What is the ending point of the second part? This is the ending point of the second part. And this is the initial point of the second part. What is the distance of ending point of the second part? As you can see, if I continue this, I will realize that the ending point would be 600. What is the distance of initial point of the second part? This one. If I continue this, I will realize that this one is 600 as well. Divided by t of ending point would be 600 and t of initial point would be 200. 600 minus 600 would be 0. As I told you at the beginning, it was clear, right? Because I have a horizontal line here. Okay, let me erase the board to make some space for myself. Let's calculate average speed for the third part. We are going to use the same formula, which was d of ending point minus d of initial point, t of ending point minus t of initial point. What is the ending point? Can you see the ending point of the third part? Yes, this is the ending point of the third part. And this is the initial point of the third part. What is the distance of ending point of the third part? If I continue this, I will realize that it's going to intersect the distance axis in 120. I'm sorry, 1200. And distance of initial point, if I continue this, I will realize that this is going to be 600. What is the t of ending point of the third part? If I continue this, I will realize that it's going to be 1000. And here it's going to be 600. So what am I going to have? I'm going to have 600 over 400. I can drop 2 zeros and I can simplify that. I'm going to have 1.5. What is the unit? Because I have this one based on meter and that one based on second. The unit will be meter per second. Let's calculate average speed for the whole route. I'm going to show it with T, which stands for total. What is the ending point of the whole route? This is the ending point of the whole route, okay? Ending point of the whole route. And which one is the initial point of the whole route? The beginning point. This is the initial point, a starting point of the whole route. What is the distance of that? It's going to be 1200. What is the distance of initial point? It's going to be 0. What is the time? 1000 minus 0. I'm going to have 1200 divided by 1000. The answer is going to be 1.2. And because that one is meter and that one is second, the answer will be meter per second. Let's solve the next example with each other. Here we have another distance time graph, and if you pay attention, you will realize that distance time graph is made of two parts. This is the first part, which is linear, and this is the second part, which is curve. The curve part, is it going to change the method that we are going to apply? No, we are going to apply the same method. We want to calculate average speed for each part and for the whole route. Let's start with the first part. As I told you before, the formula that we are going to use here, which comes from the main formula distance over time, is T of ending point minus T of initial point, T of ending point minus T of initial point. I'm talking about the first part. This is the initial point of the first part and this is the ending point of the first part, right? What is the distance of ending point of the first part? If I continue this, I will realize that this is 100. What is the distance of initial point of the first part? 0. What is the T of ending point of the first part? 2. And that one would be 0. So it's going to be 50. And what is the unit? Because this one is based on kilometer and that one is based on hour. The unit will be kilometer per hour. Let's go for the second part. I'm going to show it with S2. We are going to apply the same formula. This is the ending point of the second part and this is the initial point of the second part, right? Because the second part is going to start from here and it's going to end here. What is the distance of ending point? If I continue this, I will realize that it's going to intersect distance accessing 400. And if I continue that one, I will realize that it's going to be 100. What is the time of ending point? 4. For initial point is going to be 2. So I'm going to have 300 over 2, which is 150 kilometer per hour, which is really high. Let's calculate average speed for the whole route. I'm going to show it with ST. This is the ending point of the whole route. I'm going to show it with capital letter. And this is the initial point of the whole route. So in the ending point, the distance of the ending point would be 400. And distance of initial point 0. The time of ending point 4. And the time of initial point 0. It's going to be 100 kilometer per hour. Sometimes I have seen that the students calculate the average of S1 and S2. It cannot be correct. You must apply this method. Let's calculate the average speed for each part and for the whole route of this example. How many parts do we have? 1, 2, 3. Again, I'm going to start with S1, which is T of ending point minus T of initial point divided by T of ending point minus T of initial point. This example can be somehow tricky. Why? Because it does not start from the origin. It starts from 20. It's not popular. It's not common to see an example like this. But if your teacher wants to make a difficult and tricky example, you may face something like this. But the method that we are going to apply is completely the same. This is the ending point of the first part and this is the initial point of the first part. What is the distance of ending point? If I continue this, you will realize that this is 40 And distance of initial point, 20. What is the time of ending point? 2. What is the time of initial point? 0. What am I going to have? I'm going to have 20 over 2, which is 10. And this is going to be kilometer per hour. Let's go for the second part. Here we have a horizontal line. When we have a horizontal line, average speed is equal to 0. And I have already taught you how to calculate the value. But I'm going to write 0. You must know how to calculate this value. Because the distance is not going to change, you will have in the numerator 40 minus 40, and the average speed of the second part would be 0. Let's go for the third part. For the third part, this one is going to be ending point, this one is going to be initial point. So distance of ending point of the third part would be 60 if I continue that. For initial point, 40. For time, I'm going to have 4 minus 3. 4 minus 3. Which is going to be 20 over 1, 20 kilometer per hour. Let's go for the whole route. I'm going to show it with T, which stands for total. This is going to be ending point for the whole route, and this one is going to be initial point of the whole route. Distance of ending point would be 60. Distance of initial point would be 20. Do not write 0 because this graph does not start from the origin. And here I have 4 minus 0. 4 minus 0, I'm going to have 40 over 4, which is 10 kilometer per hour. Really easy. It's going to be really easy when you learn the pattern and the strategy that we apply. Here we have another example. How many parts do we have here? 1, 2. Second part is a curve, and third part. Third part, you can tell me the average speed of the third part only by looking at the graph. Because I have a horizontal line, the average speed of the third part would be 0. Okay, let's start. S1 is equal to d of ending point minus d of initial point, t of ending point minus t of initial point. This is the initial point of the first part, and this is the ending point of the first part. The ending point of the first part, the distance of that would be 100 minus 0. And this is going, the t of ending point would be 2 minus 0. It's going to be 50 kilometer per hour. Let's go for the second part, which is the curve. Is it going to have impact on our solution? No, of course not. This is going to be ending point of the second part, and this is going to be initial point of the second part. What is the distance of ending point? It is 300. What is the distance of initial point? It's going to be 100. When we talk about time, 3 minus 2. So it's going to be 200 over 1, which is 200 kilometer per hour. And for the third part, as I told you, because we have horizontal line, the average speed would be 0. And I taught you in the first example how to calculate that. And for the whole route, this is the ending point of the whole route. I'm going to show it with capital E. And this is the initial point of the whole route. What is the distance of ending point? If I continue this, I will realize that distance would be 300. Distance of initial point is 0. Time of ending point of the whole route would be 5. And initial time is 0. So I'm going to have 300 over 5, which is going to be 60 kilometer per hour. Here you can find more examples, and I strongly suggest you to solve them at home. If you have any question or if you wanted to share your answer, please feel free and write it in the comment box. I will try to answer them as soon as it was possible for me. Thank you for watching this video.